Hello and welcome again. So far, we understood the history of IP addressing, the home network, and the basic idea about IP addressing. Now, in this session, let's talk about the physical address without which a computer cannot be assigned an IP address. I've gone through numerous roles like desktop engineer, network engineer, system administrator, and finally into cybersecurity. Let me tell you that this is one of those basic things that you need to know before getting into this domain. If you like this session, please do not forget to like, share, and subscribe to my channel. Remember that I have explored technology in the same fashion in all my trainings so that you get to know the exact thing that is happening behind the scene. So, what exactly is a physical address and why it is so important? A physical address, also known as a media access control or the MAC address, is a unique identifier assigned to each network interface card or a computer. So, this address is used to identify devices on a network. So, unlike an IP address, which can change based on the network you are connected to, a MAC address is hard coded into the device, and this address cannot be changed. So, let's dive deeper into how a physical address is used. What are the uses of the MAC address? So, in the later section of this video, we'll be talking about DHCP. Suppose you are connecting to a network via your mobile phone or a laptop or a desktop. It means you are just connecting to a Wi-Fi network using some SSID. Then what is it that is actually happening behind the scene while your computer gets an IP address from that wireless access point? So friends, MAC address is an address which is used to identify the device which is actually requesting for an IP address while it connects to a Wi-Fi network. So let's go through the details of the MAC address and understand this further. In the last session, we discussed that a computer has two types of addresses. One is the physical address, which is also known as the MAC address, and the other address is the logical address, also known as IP address. We call an IP address as a logical address because it changes with the logic. Suppose you are at home and you connect your wireless access point, your IP address assigned to your computer could be different than the IP address the office Wi-Fi router assigns to your computer. So it could be a different IP based on the logic that we have configured it in the access point. That is the reason we call IP address as a logical address. So जैसा लॉजिक वैसा IP address आपको आपके कंप्यूटर को मिलेगा. But when it comes to physical address, this is a hard coded address. When a network adapter is manufactured, the manufacturer hard codes that MAC address into that network interface card. So it could be, yeah, the NIC card on your laptop. It could be any other network device, example router, switch, or Wi-Fi access point. So all these devices connect to each other, but for them to have their own identity, the MAC address is mandatory. As you can see on my screen, I have captured a sample MAC address. So this is the MAC address. So let's understand this in little more details. So if you look at this address, this is a 6 field address. So there are 1, 2, 3, 4, 5, and 6. So there are 6 fields separated by dash here. So it could be separation by dashes or it could be a colon. When it comes to logical address, the address is divided into 4 parts. Example 192.168.1.109. So let us try and understand the MAC address syntax. This is the syntax of a sample MAC address. So this MAC address consists of 6 pairs or 6 octets also known as hexadecimal digits separated by colons, dashes, or hyphen. So as you can see here, it is a colon, it could be a dash or a hyphen, depending on the vendor, depending on the operating environment you are working on. It either shows a colon, dash, or a hyphen. Each pair of digit represents a byte here. Okay, so please note that MAC address is denoted using hexadecimal notation. So when it comes to hexadecimal notation, the smallest number could be 00 and the highest number could be FF. So if we want to build an analogy, 00 in hexadecimal means 0 in decimal, and FF in hexadecimal is 255 in decimal. This address works at data link layer. So if we have not gone through my OSI model session, please go through that so that you get to understand what is data link, what is network, and other layers in the OSI model. So there you can get all the details about different layers of an OSI model. So important thing to note here is MAC address works at the data link layer, and every computer, every smartphone, or every network device that has the ability to connect to a network, it means it has a MAC address hard coded by the manufacturer within that network adapter. So, as we discussed, this is hard coded into the NIC, that is network interface card, by the manufacturer. So, the technology that we used in networking is IEEE 802 network technology, and this MAC address supports that technology. So, it could be a wired or wireless network. If you want to understand or analyze the significance of these hexadecimal numbers and understand what is its decimal equivalent, you can visit this particular URL. Definitely, there are many URLs that you can visit. Example, I'll first show you the rapid tables. Let me open Google Chrome. Rapid tables hex to decimal converter. So this is the URL that you can access. Example, I want to convert a hexadecimal number to decimal. I can simply put 00 and ask for it to convert. So the decimal equivalent is 0. So if I want to identify the conversion of FF converted, you will get 255. The important thing to note here is that these numbers are these two digits are nothing but this is a byte, and the lowest value could be 0, highest value can be 255. So with this, I hope you understood the MAC address. So very important thing to note is that it is a 6-field hexadecimal number separated by colon, dash, or hyphens. Now moving to the next slide, MAC address. So this is the permanent address assigned by the manufacturer to the network interface card, and this address ideally cannot be changed. So, but in some cases, I have come across where we talk about blade enclosures, high density servers, or virtualized environments. You can change this MAC address because sometimes the application licensing also depends on these addresses, and in case of hardware changes in the IT environment, we cannot afford to lose the license, right? So in some cases, even if the hardware is changed, we need to retain the older MAC address on the hardware so that you can continue to use those application licenses. um, in some cases, as I said, this MAC address can be changed, but the common notion amongst the security community is that it cannot be changed. But note that uh, it is not the only thing to secure the network, but the hackers can very well spoof the MAC address of a computer to impersonate the user. So it's important to note that while the MAC address is unique, they are not necessarily secure, right? So they can be easily captured and spoofed by attackers, and they should not be relied upon as the sole means of securing a network. Let me quickly show you the how you can identify the vendor. Suppose I have this MAC address, I'll just copy it and MAC vendors. On this URL, you can simply copy the MAC address and immediately it will tell you the vendor of that particular network interface card. So I have copied MAC address of my computer here. I can see that this is the Dell uh, computer. So this is how you can easily understand the vendor of the device. Sometimes what happens is networks are compromised by the attackers, and in some cases where the criminals were caught successfully, uh, I can quote numerous examples, but the way those attackers or hackers were identified was using the MAC address that was assigned to their devices. So when the network transaction or network communication happens, most of the times server environments or applications capture the MAC address of the computer that is connecting to their application or the server, and that's how there is a chance that you can track back that MAC address to identify the culprit who actually compromised the application. With this, I hope you understood the concept of MAC addressing. So you can use MAC vendors to identify the vendor of your network adapter, and this can be done using the MAC address that is assigned to your computer. A very important thing that you should be knowing about the MAC address is nothing but the reason why it is important, right? So consider you have a mobile phone. Example, I have my phone here and I'm just trying to connect to Wi-Fi. So what I'll do is I'll search for the SSID by enabling my wireless network adapter. I'll search for the available network. If I'm at home, I'll just simply click on the SSID of my home network and I connect. But the wireless network adapter on my phone can only receive an IP address from the wireless access point only if I have something unique on my phone. So while we are talking about MAC addresses, it is the only thing that is used while my phone connects to a Wi-Fi network. DHCP process, when we talk about, so it is the process that takes place while you connect to some network using Wi-Fi or a wired connection. So here on this screen, there is a computer which is now trying to receive an IP address, right? So this is the DORA process that we are going to discuss. So DORA stands for discover, offer, request, and acknowledge. So these are the four phases of the DORA process during which an IP address is assigned to a computer from a DHCP server. So it's not necessary that it should always be a server, but it could be a wireless access point that you may have at your house and that is configured with DHCP protocol. What happens is uh, the DHCP, the protocol uses UDP service, which is user datagram protocol. So here only one way communication happens. There is no need of acknowledgements to be received because this process is fault tolerant to the TCP model. Because if it uses TCP, then DHCP server will always try to look for whether the client has received an IP address or not, right? But if in some cases, if this communication doesn't happen, the DHCP server may get hung. So that's the reason it uses user datagram protocol. And now, in the first phase of this DORA process, the client first sends the DHCP discover message, which then gets sent to all the computers on the network, right? So the DHCP server usually operates on port 67 and the client operates on port 68, right? So this is the port number 67 and 68, which is being used by the DHCP DORA process or the DHCP protocol. First understand what is the DORA process. So if you look at here on the left side, this is the client listening on port 68. So what happens during the first discover phase that this computer does not know the IP address or the MAC address of the DHCP server on the network, right? So initially, the computer itself does not have an IP address, right? So what it does is it will first send the discover request, and this while the discover request is sent, as this computer does not have an IP, the source IP by default considered is 0.0.0.0, right? In the later section of the IP addressing, I have discussed that there are two addresses that are not assigned to a computer, right? 0000 and 255.255.255.255. So this is where the network ID or the network address 0.0.0.0 is used. So the request is sent with the source IP as this, the network ID, destination address. This is the 255.255.255.255. As this computer doesn't know who is the DHCP server on the network, it simply broadcasts the request. What does that mean? When the message is sent to an IP 255.255.255.255, what it does is it sends that request to the entire network. So there is only one server on the network which is actually listening to port 67, and that is the DHCP server or DHCP service configured on the server or the wireless access point. So what happens while the DHCP server is listening on port 67, it understands that somebody on the network um, with a source IP this, which is the network ID, wants to get an IP address, right? So what happens when the request is received from the client? The source MAC address of this machine is attached in the request. So when the source MAC is sent, it is the client's MAC address, but destination MAC address is not known to this computer. So it is again the broadcast hexadecimal number or the MAC address which is used. This is again, if you understand, this is nothing but 255, right? So this is the broadcast MAC. So broadcast address used in the MAC address. So the first phase is to identify the DHCP server on the network, right? So if you look at the source and destination IP and source MAC and the destination MAC on the network layer, we can see there is a layer 3 broadcast. And if you look at the MAC address, so here you can see the client is also making the data link layer broadcast, right? So this is also known as layer 2 broadcast. Now moving next, the offer. In the offer phase, what happens is now the DHCP server got to know the MAC address of the source, right? So if we go back in the discover phase, client has sent the MAC address, right? So this has already informed the server that this is my MAC address. So in the offer phase, DHCP server assigns its own IP address in the source IP, which is the DHCP server IP. Destination, as this computer has not received an IP yet, so DHCP server does the broadcast this time. But while sending the reply, DHCP server assigns its MAC address in the frame, and destination MAC address is the MAC address that was received from the source during the discover phase. So here in the offer phase, the network layer broadcast happens. So if you look at the destination address, here DHCP server does network layer broadcast, that is also known as layer 3 broadcast. And if we look at the destination MAC address, it is a data link layer unicast. Now in the offer phase, the DHCP server has already got the MAC address of the requester computer. So moving to the next phase, now this computer now requests the DHCP server, the source IP. Again, still this computer does not have the source IP, but again a broadcast is done. And source MAC address is the client MAC address that is assigned, and destination MAC address is the DHCP server's MAC address. So far now the destination address IP, so the request goes to the DHCP server. So here again network layer broadcast happens, and on the frame level, it is the data link layer where the layer 2 unicast happens. Now going back, the going to the next phase, the acknowledge phase. Here the DHCP server replies back to the request with network layer broadcast, and the source MAC and destination MAC is already known. So this is the layer 2 unicast. So this is how the process takes place. So the first discover process broadcast happens. The DHCP server identifies that somebody is requesting. It replies back to that computer, and in the offer phase, in the request phase, the client connects to the DHCP server, and finally, DHCP server assigns the IP address to the requester computer. During this process, you might have observed that MAC address plays an important role because unless and until the DHCP server gets to know the requester, it will not be able to assign the IP address. So one thing to note here is to receive an IP address, MAC address is required. So to recap, we understood the DHCP protocol, the DORA process, the role of MAC address while getting an IP address, and how the IP address is assigned. So why DHCP is called a protocol, right? This is a usual question I ask to my students. So friends, always remember, you can connect to any network using DHCP, right? You are using your phone, you are using your MacBook, you are using your iPad, or it could be a Windows laptop, right? And the concept is the same, right? So when you connect to your phone to a Wi-Fi router, DHCP is there. When you connect your laptop to a router, DHCP is there. If you are using Linux operating system, again the same concept. Your Linux or Windows or Android or Mac OS is able to get an IP address from the router. So the very important thing to note here is that protocol is called protocol because it is always platform independent. So DHCP is pronounced to be a protocol because it works on Windows, it works on Linux, it works on Mac, or it works on any other platforms like Unix. So friends, understanding the concept is very important. So I think with this you got to understand the MAC address in detail, how to identify the vendor, how it plays an important role in the process of receiving an IP address from a DHCP server. And now let's move on to the next session where we are going to talk about the IP address. Thank you.